Sir Isaac Newton formally published the equations of motion in 1687. These equations are related to the laws of motion. But how can we know whether a given equation is correct or incorrect?
Excuse me, sir. How can I test the validity of the equation, sir?
There are different methods to check the validity of an equation. One simple method is the unit analysis method. For our class, we can easily check whether a given equation is valid or invalid using this method. What is the unit analysis method? The unit analysis method is a method in which the units of physical quantities on both the left-hand side and the right-hand side of an equation are compared. An equation is considered valid only when the units on both sides are the same. For example, question number 1. Check the validity of the given equation. Here, v represents final velocity. U represents initial velocity. A represents acceleration. S represents displacement. We know that the SI unit of velocity is meter per second. Similarly, the SI unit of acceleration is meter per second squared. And the SI unit of displacement is meter. To check the validity of the equation, we take the left-hand side and the right-hand side of the equation and replace each physical quantity with its SI unit. Then we compare the units on both sides. In the above equation, the units on the left-hand side and the right-hand side are the same. Therefore, the given equation is valid. Remember, for an equation to be valid, the units on both sides must be the same. It does not matter if the numerical values or coefficients are different. Let's take another example here. Neva claimed an alternative formula for power and pressure in the given question. If we read the question again, there are two different conditions for two different physical quantities, which are power and pressure. We can use the unit analysis method to check the validity of both equations. So let's take the first physical quantity, that is power. What we know is that the formula of power is equal to work done divided by time taken. So the fundamental unit involved in power is calculated as kilogram meter squared per second cubes. Now according to Neva, power is equal to mv square where m refers to mass and v refers to velocity. Now changing into fundamental units. Since the units of power and the units of the formula claimed by Neva do not match, her formula is invalid. Similarly, for the second condition of pressure, we know pressure is equal to force divided by area, so the fundamental unit is as shown in the picture. Now Neva claimed another formula for pressure as mv by a. Remember, smaller refers to acceleration where capital A refers to area. So changing into fundamental units, the units of pressure and the units of the other formula claimed by Neva do not match. Thus, this formula is also invalid. Now it's your turn to copy down and practice this question. Have a good day.